Okay, good morning, everybody. My name is Pedro de Bruyckere. I'm from Belgium, uh, Ghent, the fine city of Ghent. It's very cloudy over here. If you have any complaints about me, you can put it in the chat, but you can also put it on Twitter. But please do mention my handle, the Band B. Um, I'm the co-author of Urban Myths about Learning and Education, and I also co-authored the follow-up book, More Urban Myths about Learning and Education. And after all those myths, I was also asked what does work, and that led to the ingredients for great teaching. But I won't be discussing this today. I want to talk about an article I co-wrote um, about a science of teaching rather than learning. It's an article I co-wrote with David Daniel from the James Madison University toward an ecological science of teaching. And I will explain what we try to propose in this article, and it will also be an explanation how research and teaching can influence each other. And we both think, both David and I, that there are still a lot of opportunities who aren't being used. Now, to be clear, cognitive psychology has taught us a lot. Um, we've all heard about um, spaced repetition. We've all heard about dual coding. You know, all those things are great. And we've learned about them because of cognitive psychology. They taught us how we learn. And quite often people make the mistake thinking that if we switch this, if we know how we learn and we switch it, then we know how we should teach. But it's not that simple. Now, why isn't it that simple? Well, to understand why it's not as simple, we have to look to the differences between scientists and educators. And I know that there are a lot of people who combine this function, but still, I want to discuss four things with you. What do teachers and scientists have in common? What are the main differences? And how can we solve this? And I'll end my thing a bit like Steve Jobs, one more thing. I hope this is okay for you because I can't change it anymore, but bear with me, it will be interesting. Now, what have teachers and scientists in common? Well, we all want better education. Well, I hope so. And both teachers and scientists do not always agree what better education means. Um, we know that there are more progressive teachers, more conservative teachers. In practice, they are very similar, but when you start discussing things, you can have very different opinions. Also, if you look at scientists, we know that there are different paradigms. We have more cognitive scientists aiming at stuff like cognitive flow theory and things like that. But we have to admit, there are also scientists who are more social constructivistic inspired. And I only mentioned those two elements, and then you think there's a kind of dichotomy. No, no, it's much, much more complicated. And for me, this is a good thing because of those discussions, we can move forward. And both scientists and educators hate complexity. To explain this, I was wondering, and you can answer in the chat so I know that you're alive. Um, do you know this game in Sweden or wherever you are watching this? Can you answer in the chat, please? Okay. Ami Barkulun says Victoria, but Sunny or Lakshmi Sunny doesn't know it. What is this game? I'll explain to you. We give a lot of sticks. We put them. We let them fall on the table, and then you have to take one piece, one stick by stick. And if another stick moves, then you lose your turn. You have to switch. Most of you know it, but I hope you understand the game now, Lakshmi. Okay. Now, for me, this is the perfect image to describe reality when you are discussing education. For instance, we are working on prior knowledge. with pre-teaching, but at the main and in the same time, in the meantime, we also maybe tell children unconsciously that they are not that good. So we take one stick, but another stick is being moved. And now there are several different ways that scientists and teachers react. So let's move on to what are the main differences between teachers and scientists. First of all, when we are discussing dealing with complexity, well, teachers, how do they react? Well, they have to deal with it. Quite often, they actually accept it and they will state, let's look at this from different angles and not let's not reduce children to one element. Actually, I hope teachers have this reaction. That's also why we have teacher meetings where they discuss the different pupils, just to make sure we look at situations from a different angle. I'm teaching in teacher education. I'm a teacher trainer, and one of the main um, goals of my classes of psychology is to show future teachers that if you have one behavior, quite often there can be different reasons why this behavior is taking place. But even more, quite often it's an interaction between different reasons why this behavior is happening. So if a student didn't do his or her homework, well, he or she maybe has forgotten it, but maybe there's a bigger complexity behind it. And a lot of teachers know this. So they say, we know this complexity, we have to deal with it, we have to accept it, and sometimes it's even good to accept it. Now, what's the typical reaction of scientists? Let's get rid of all the other sticks and let's look at just one element and try tricks to eliminate this complexity. Now, the perfect example is what we call the golden standard of research: randomized controlled trials. Okay, looks good. You've all heard about this when we were discussing medicines. We take one group who gets a new medicine and the other group gets a placebo, and then we look what's the result. We've seen this with the vaccines, for instance. We're hearing about this now with new medicines for against COVID. So we can do this also in education. And I'm doing a randomized controlled trial at the moment. I'm finishing one in the Netherlands about tutoring. And it's interesting. It's very interesting to do this. So we take two groups, and one group gets a kind of approach, and the other group doesn't. But wait, it also gives an important limitation to research, because quite often some things aren't necessarily possible in a randomized controlled trial. Let's give a very simple example. Um, if you look at research about class size is a heavily debated topic in educational research, but most of the studies are correlational because they won't have a randomized controlled trial. They just most of the time look at, for instance, PISA or PEARLS data or TIMSS data, big data sets where countries are being compared or regions are being compared, and they look at the results, they look at the average class size, and they say there is no effect. There are only a couple of, one of them is actually a Swedish study where children were put randomly in different groups, but this makes it very expensive because it takes a while, and also you have ethical questions because if children are being put in a one way or another, is this the best thing to do? The same is happening in medicine. Before you can do such a kind of study, it takes a lot of ethical hoops to go through because, you know what, is it fair, is it safe, things like that. Another example is growth mindset. There have been quite a lot of randomized controlled trials on the effects of growth mindset. Great. And Carol Dweck has become really famous because of this. But because randomized controlled trials are often very expensive, no, they are, trust me, and time consuming, then quite often, in the case of growth mindset, there were very small sample sizes. And when in 2018, people did a meta analysis on all those small studies, most of them seemingly showing a huge effect, they discovered that on average, working on a growth mindset has a small effect. Now, to be clear, it's not about the existence of a growth mindset or a fixed mindset. For the people who don't know it, growth mindset is the idea that you can change, that you can learn, that you learn from feedback, things like that. While fixed mindset is I'm smart, I'm not, things like that, and I can't change it. That people have this kind of mindsets, that's true. And that this kind of mindset can have an effect, also proven. But can we change this mindset by, for instance, saying instead of saying to a child, "You're a very smart child," no, you can't do it yet, or you achieve this by working hard. Can we change this mindset, and has this an effect on the learning? Well, if you look at the meta-analysis, then on average it's a small effect. And when they did do a huge study with enough children participating, a huge replication study with enough children, almost 12,000 children, and actually Carol Dweck was also one of the authors of the study, on average they didn't see any effect. Now, to be clear, even some recent studies have shown a possible negative effect. But now comes a very interesting thing. Because of the approach of working with a randomized controlled trial, eliminating all the other elements, it becomes much more difficult to understand why it doesn't work with some groups, and maybe with some groups it does work. In this case, we have a clue. We know that, for instance, older students are and stronger performing students often have the idea that a growth mindset approach, can be insulting. While we also know, if you look deeper into the details, that, for instance, children from a poor background, younger children, can benefit. But in this case, in the study in Argentina, they worked with younger children, they worked with children with lower social economic background, and it also had a negative effect. So it's very complicated. And to find this complications, to understand these complications, we always say we need more research. Now, what I want to explain is that randomized controlled trials, by eliminating the complexity, quite often doesn't tell us how to deal with that complexity. A second element is how to deal with significance. And that's also a second possible issue with randomized controlled trials, but not only with randomized controlled trials. The main question is, compared to what? Besides a great song by Roberta Flack, no, really, it's a great song, look it up. It's actually the main issue when we are doing randomized controlled trials in education. Let me explain this. In medicine, we often use one medicine and compare it with a placebo. But what can be the placebo in education? For instance, I know from a study in the Netherlands where they examined the effect of learning while doing exercise. Okay, so one group did the exercise while studying mathematics, and the other group didn't. They just learned mathematics. And now you think, oh, that's a good thing to examine because one is doing the exercise, the other doesn't. Yeah, but wait, we know there's some studies that showed that doing exercise before or after doing mathematics can help. So in this case, is it because they are doing exercises while studying, or is it just because of them doing exercises? This makes it much more complex. Compared to what? Now, um, do we compare new stuff versus business as usual? Maybe a better idea is um, new stuff compare new stuff to a known effective approach. And this makes it much more complicated, but then both get something new, so we don't have a Hawthorne effect. For the people who have never heard about it Hawthorne effect, this means that you have an effect because you are doing something new. So if one group is trying something new, but the other group is doing business as usual, they don't have the Hawthorne effect, for instance. But for scientists, well, let me show you this cartoon to explain. The evolution of academia, publish or perish. Then we need to publish in high impact journals or perish, publish frequently in high impact journals, and maybe you won't perish. If you don't find a significant difference between one approach and another approach, it's really hard to get published. Sheer impossible. It's getting better now lately, but this is one of the main reasons why we have something called a publication bias. But wait, for teachers, it can be very, very different. Because if something isn't significant at all, maybe this is a good thing. Well, let me explain this. Oh, sorry. For instance, if you have two approaches being compared, and one approach we've known that it's effective, and the other approach is as effective, for the researcher, this is bad news because if you compare them both, there will be no significant difference between the two. But for teachers, it means you can use them both because they are as good. So for scientists, this is bad news. I won't get published. And actually, a lot of teachers won't hear about it because it won't get published. But at the same time, it's crucial, very interesting information for teachers. Now, let's look at how to solve. Now, first of all, if we look at the issue of randomized controlled trials and the example I gave about growth mindset, we need more replications. Why does it work here and less there? Why does it work with this group and why doesn't it work with that group? But also, we need to get non-significant results published. Because otherwise, how can we know about this? Now, the good thing is, and that's a really good thing, that in psychology, uh, more in psychology than in educational research, we now get, because we have had a replication crisis, more about that in a second, um, we can pre-register studies. For instance, the randomized controlled trial that I'm doing in the Netherlands now was pre-registered. We have traces of this has been done. This research is planned and is conducted. Maybe it won't lead to an article, but you can find traces when you do, for instance, a meta-analysis. You can find traces of that study, and you can check, did that study happen or not? Did it get published? No, but you can contact the scientist and ask them, why wasn't it published? Maybe you didn't do the study, or maybe it's because you didn't get a result. But also, luckily, nowadays, more and more journals, because a study is pre-registered, well, they will publish it because we are now uh, trying. Well, they try to understand now that it can also be relevant to know what doesn't work. But there is another important solution. We should stop looking for the king of the mountain. And I'm not against John Hattie. John Hattie has meant a lot for educational research. Because of him and also people like Marzano, we have tried to work more evidence based and later more evidence informed. But by looking at visible learning and the rankings of things that could have an effect in education, we have been looking at the King of the Mountain, what has the biggest effect? And then you get interest in collective teacher efficacy because that's the number one at the moment. And it's interesting, but I know from my own work that working on collective teacher efficacy takes a lot of time, energy, effort. So we have a huge effect, but that huge effect costs a lot of effort. Maybe we should also have a look at low hanging fruit. For instance, growth mindset. Again, we now know that growth mindset doesn't have that big of an impact. It has an impact, a significant impact with some children, but it doesn't cost any money or energy. So maybe you can also take that lower hanging fruit and look at your pupils, your children, if it has a good effect or not. If it doesn't have a good effect, try something else. That's what every good teacher would do. So, by looking at the low hanging fruit, we will be a better teacher, I think, than by looking at the king of the mountain. What's the best thing to do? Now, one more thing, and then I will open the floor for questions. Um, a couple of years ago, I wrote the book, The Ingredients for Great Teaching. And I'm not pushing this book, but it's a great book. Now, what's next? In July of next year, we will publish, Casper Hulshoff, Lies Messine, and I will publish The Psychology of Great Teaching. Almost everything teachers ought to know about psychology. Because, like I said, psychology has been in a replication crisis. So, what does this mean? Just I wonder, have you heard about replication crisis? Just say yes or no in the chat, please. Pastor has heard about it. Victoria hasn't heard about it. And the okay, more already 3 people said no. Other people still have an answer for me? Trial design is a wicked problem. Trust me, it is. Okay, I'll explain to you. The replication crisis, sorry for the people, Sarah and Pastor, who have heard about it, but maybe I'll give you some new insights extra. I'll keep it short, so I'll leave the floor open for the questions. But the replication crisis, what's that? Since 2011, the past 10 years, we've had in psychology a lot of replication studies. What is a replication study? Doing exactly the same study over again. And it has been a huge crisis. For instance, in social psychology, 2/3 of the studies that were replicated failed to replicate. So it's has been a slaughter. In cognitive science, actually, it's not that bad. And quite often people look at the replication crisis as a bad thing because a lot of the things you've heard about are wiped away. For instance, maybe you know that study where you take a pencil and you put it in your mouth, and because of you putting this pencil in your mouth goes like this, and you will feel better. Yeah, they replicated it, I think, 13 times. Every replication failed. So if you have heard about the study, forget about it. And there are whole fields of research being washed away in psychology. For me, this is a good thing. Actually, it shows that science, works and does do self-cleaning. And what people often forget, those replications that actually were a success makes those insights much stronger. So we know some stuff better than ever, and we know from a lot of other stuff it's incorrect. Maybe an infamous example that already was debunked before the replication crisis, but not a lot of people know about it in education, is Jean Piaget. Most of his theory has been debunked. I know everybody in teacher training across the world is learning about his different stages. That doesn't exist. They learn about a lot of his experiments that have been debunked. So Jean Piaget is actually somebody who is off the table. The irony is, if you take Jean Piaget into account in education, quite often it has a good effect, but it's not because his theory is correct, but it's because you are working quite often multimodal or more concrete, and this can help. Now, in our book, The Psychology of Great Teaching, we tried to summarize what is still standing. So we have made a summary of everything that can be relevant for every kind of teacher from the different corners of psychology. So not only from cognitive psychology, but also from social psychology, also from developmental psychology, but also behavioral economics, a lot of different areas of psychology, and we try to summarize what is still standing after the replication crisis and can be relevant and handy for you as a teacher. This book is coming next year. Okay, this is what I wanted to share with you. Thank you very much. And now the floor is open for questions, comments, and I'm looking forward to answer them.